The triangle starts off with the number 1. Crazy, I know. Every number on the outside of Pascal's triangle, right and left, are 1s. Okay? And then you take the numbers on the outside and you add them up to get the next one. So this one has to be a 1, this one has to be a 1, and 1 plus 1 is 2. So that hits in the middle. Okay? Then you're going to start off with a 1. Then you add these two numbers. 1 and 2 is 3. Then 2 and 1 is 3. And then you get a 1 on the outside again. I'll show you the correlation when we start using the binomial theorem in a second. Then you just keep going. 1 on the left. 1 and 3 is 4. Oh, I switched computers thinking it would fix the problem. Nope. 3 and 3 is 6. 3 and 1 is 4. And then 1 on the outside. At least it's just staying there. So, and then we have a 1. 1 and 4 is 5. 4 and 6 is 10. 6 and 4 is 10. 4 and 1 is 5. Then we get a 1. And you just keep doing that. 1, 6, 15, 20, 15, 6, 1, etc. Right? We'll just keep going. That's Pascal's triangle. How it correlates with this unit in a second. Okay, I can get you to flip over. Maybe not. Did I? It went ahead. Okay, I want you guys, when you see 3a minus 2 squared, what should you do every single time before you start? What does that even mean? 3a minus 2 squared. Yeah, you multiply the term by itself. It means you have 2 of them, right? Like a squared, I could write out as a times a. A cubed, I could write out as a times a times a, right? So what I always say is if you don't write it out twice, you'll probably miss the middle term. A lot of people will tell me this is 9a squared plus 4. And you miss the middle term. Okay? So square the first term, square the back term, call it a day. That'll be an error that's there, and it's wrong. So when you get 3a minus 2, I'm like, thank you. Cool. I'm going to rewrite that, though. So I have 3a minus 2 squared. And the first thing I do is I cross off the squared and I write it out again. Like, thank you for your short form, but I'm going to actually write it out twice. So that I don't miss the middle terms. The people who do not write it out twice miss the middle terms every single time. Okay, go. Try it out. We will always use proper terminology. Okay, when you have another term plus a term, or one term plus a term, or one term minus a term, what's that called? Binomial. When there's 3 terms, what's it called? Trinomial. So this is a binomial times a binomial, correct? And you were taught when you had a binomial times a binomial, you could use the acronym FOIL. You aren't foiling, you're still distributing. Anytime you take one term or 2 terms or whatever terms and then other terms and you distribute them into each other, it's called distribution, right? You're distributing. That's always how it is. So the moment I start multiplying things, I'm distributing. That's what's happening. But you can use the acronym FOIL to do it. First, outer, inner, last, when you have a binomial times a binomial. So 2 terms times 2 terms. The reason why that works is every time you distribute one bracket into another, every term in this bracket has to be multiplied by every term in this bracket. So FOIL just happens to come out with 4 terms. The 4 terms come from multiplying the first ones, the outsides, the insides, and the last. It's just kind of a fun thing to help you out. But you're still distributing. So we have 3a times 3a. 3 times 3 is 9. a times a is a squared. And then I have 3a times negative 2. So I did these, and then I did these. So I get negative 6a. Negative 2 times 3a, negative 6a. Negative 2 times negative 2 is positive 4. And then I collect anything with like terms. 9a squared stays the same. Here I have negative 6 apples, and I minus 6 more apples. I get negative 12 apples plus 4. Now, if people forget to drop the squared and write it out twice, I often get 9a squared plus 4, missing the middle term. Right? And we don't want that to happen because that's actually wrong. All right. How many terms are there after I've expanded it? How many terms? Don't know. There's 3. 1, 2, 3, right? There are 3 terms. What is the connection with the number of terms and the binomial? 3a minus 2 squared. This is the connection. It has something to do with this number. That's a 2. We get how many? 1 more every time. So every time you have a binomial, it's the binomial theorem. It's the reason why it's called the binomial theorem. It's called the binomial theorem. The binomial theorem is this little formula down here, and we'll talk about it. It's called the binomial theorem because it's whenever you have a binomial, something with 2 terms, and you square it, cube it, 4th, 5th, 6th, 7th, 8th, you can use the binomial theorem to solve for different terms. So the key thing here is the total number of terms is always the exponent plus 1. And if you forget, expand out a binomial to the 2, right? If you expand a binomial squared out, you'll always get 3 terms, which is always 1 more than the exponent. Okay? So, binomial. Since it takes quite a while to expand a binomial, the binomial theorem gives us a shortcut in order to come up with any one term without finding all the terms in the expansion. The binomial theorem on our formula sheet that we need to understand. So I printed the formula sheet, I just got to get the plastic sheets. So here we have the binomial theorem. Now you might be like, why would I use the binomial theorem, which is long, if I could just expand it? Well, x plus 3 squared is easy. What about x plus 3 to the 9? X plus 3 times 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 x plus 3. You have to distribute, and get more brackets, then distribute, and get more brackets, and distribute, collect like terms. Are you going to make an oopsie possibly? Yeah. So a lot of distribution. So when it's to the power of 2, yes, it's easy to expand it that way. Also, this will get you one quick term. Like the 5th term, I can find really fast using this. If I add it to the 9th power, I'd have to expand it all out, put it in descending powers of x, and then find the 5th term, which would take me a while. So here, we have tk plus 1, and this seems way more overwhelming than it is. If I get your full attention this whole class, this is not a hard lesson. It's a lot of plugging it into a formula, getting out an answer. Okay, so let's pay attention. So we have tk plus 1, nck, x to the n minus k, y to the k, where tk plus 1 is the term you're looking for. So remember in the very first unit in 20-1, you guys did arithmetic sequences in series and geometric sequences in series? Yeah? All I care is that you know when it said this, what did that make you find? Second term. That's what I want you to pull from grade 11. That means finding the second term. Okay? So if I'm using this formula, guys, and I want the second term, I want T2, correct? Everyone's paying attention on the calculators? I want T2. What would K have to be in order for that to be the case? K would have to be 1, right? 1 less. So it would be 1 in this case. If I wanted term 7, what would K have to be? 6, because 6 plus 1 is 7, right? So that's why K is always 1 less than the term you're finding. Your N, they give you the formula on your formula sheet. It's like this: x plus y to the n. So x is always this one, y is always this one, n is always this one. The only thing that changes is your k. Your k changes depending on what term you're looking for. But n, x, and y always stay the same. Like I said, it sounds way more complicated than it is. So we're going to go through the exact same question. Do you see this? 3a minus 2 squared. 3a minus 2 squared. The exact same question, but we're going to use the binomial theorem to find the 3 terms. Now you might be like, well, it was way faster to just distribute up there. Yes, because it was a squared. But if I give you to a 9 or an 11, I promise you, binomial theorem might not be way faster, bless you, but it'll be way less mistakes made. Okay? So, binomial theorem doesn't find all the terms at once. It finds term by term by term. Okay? So I know that because this is a 2, I'm going to have how many terms? 3 terms, correct? So is 1 more than that exponent. So I know I'm going to have to find term 1. I know I'm going to have to find term 2. I know I'm going to have to find term 3. Right? There's going to be 3 terms I have to find. Do you agree? The binomial theorem Didn't know I was doing. So on the bottom left, it says, in the expansion of x plus y to the n, written in descending powers of x. It'll always be written in descending powers of x. And when they ask the question, they'll say, determine the term 5 in the descending powers of x. They have to say that because you could do the terms in the opposite direction. This formula always does it in descending powers of x, so don't let that throw you off. Okay? Now, it says x plus y to the n. It has to be in that form. Does ours have a plus sign in between it? No. So we have, technically, 3a minus 2 squared, but I need to have a plus sign in between. So I'm going to go 3a plus negative 2 squared. So my x is 3a. My y is not 2. My y is actually negative 2, and my n is 2, because it gives you in the form x plus y to the n. So you have to watch yourself. Do you see how there's that minus sign has to be, the y has to be negative 2, not 2? Do you think they'll have the answer to y being 2 as well? And you forgetting to put the negative sign with it? Yep, they absolutely will. Common error. Okay? So my x and my y and my n never change. My x is 3a, my y is negative 2, my n is 2. That's not changing. My k will change, though, every single term. Because the formula is t k plus 1. So my formula is t k plus 1 equals nck. I'm just writing it here. It's literally above, but you guys have it on your sheet, but I can't see it. nck x to the n minus k, y to the k. That's the formula, correct? I want term 1. So what am I going to go? What is k going to be? T 0 plus 1, correct? Do we agree? Because I want term 1 in the end. So I'm going to go t 0 plus 1. So I know for this one, k is 0, correct? What's k going to be for this one? This one, k is going to equal 1, because I'm going to have to go t 1 plus 1 equals. And this one, k is going to have to be what? 2 plus 1. Get that 3. So my k is 2. So the only thing that changes is k. X, y, and n always stay the same for every single one. All right? Okay. So let's fill in the formula. So we get t0 plus 1 equals, n is what? 2. C, what's my k for this one? 0. This is why this fits in the unit of perms and coms, because you have to use the combination to get this 2c0. That's it. That's the only reason why I think. And then we get x, which is actually 3a, to the n minus k. So n is 2. K for this one is 0, so minus 0. What is y? Negative 2 to the k, which is 0. Does everyone see where I pulled the stuff from? Okay, so t0 plus 1 is t1, which is what we need. If I have two objects, I choose none of them. How many ways can that happen? 1. I literally look up and I say, I don't want any. It's one way. Now, anything C something or anything P something will never result in a 0, just so you know. It'll always result in a 1 at minimum. So 2C0 is 1. Then 2 minus 0 is just 2, correct? So I told you common error is going to be to not take the negative with the y. This is the second common error, grade 10. You guys would rarely mess up on a grade 12 outcome. You guys would mess up on your grade 10 outcomes, just so you know. This is exponent laws. Where does that 2 have to go to? People will tell me it's 3a squared. Is it 3a squared? And you had this 2. This is why you learned exponents in grade 10. I wish they had them in grade 11 as well, but for some reason they dropped them off. The 2 has to go to both things, correct? Remember in grade 10 you were taught that? So this isn't 3 times 2. The 2 joins onto here, right? So this is 3 squared, which is what? 9. Do you think they'll have the error there where you forget to square the 3? They absolutely will. It's common error. So 3 squared is 9, and then we get a squared, and that's in brackets. So 2c0 is in bracket. is multiplied by 9a squared. What's negative 2 to the 0? 1. Anything to the power of 0 is 1. When I used to get to teach grade 10, I used to draw a pig. I would go like this. It's so good. You guys will be so jealous of my pig. I even put it on a quiz. Give him some feet. I like to give him shoes too, because you don't want to. And then I would go like this. And your answer is 1. Because it doesn't matter what you raise to the power of 0, it's 1. Does everyone know why that is? Let's understand why. So, if I have 2 to the 1, what is that? That's 2 one time, right? So it's 2. What about 2 to the 2? That's 2 times 2, is it not? Which is 4. Okay, 2 to the 0, we're going to see what that is. 2 to the negative 1, do you remember what that is? Grade 10. When you have a negative exponent, what can you do? Drop it to the other spot and make it positive. So if it's in the numerator, you drop it to the denominator, make it positive. If it's denominator, you drop it to the numerator, or raise it to the numerator. So I'm going to drop that down. I'll have a 1 in the top, and then I get 2 to the 1, which is actually a half. So the difference between these is multiplication and division of 2. So if I go 2 times 2, I get 4. If I have a 1 divided by 2, I get a half. So this one always falls in my 1 because it's exponential loss. It's multiplying by 2. So 1 times 2 is 2, 2 times 2 is 4, 2 cubed is going to get me 8. 1 divided by 2 is a half. 2 to the negative 2 is 1 over 2 to the 2, which is a quarter. That's why you always get 1 in the middle. Anything to the power of 0 is 1. All right, let's go back to here. So negative 2 to the 0 is 1. What does multiplying by 1 do? Nothing. Term 1 is just 9a squared. So when I go to write out my trinomial, and I know this has 3 terms because we discussed this, it's 1 more than n, my first term is going to be 9a squared. Cool. So my answer is going to be 9a squared, something, something, something. Okay, let's find term 2. Term 2 is t to the 1 plus 1, so k is 1. So I'm going to get n, which is 2, ck, which is 1, times x, which is 3a, to the 2 minus 1, n minus k, and then y, which is negative 2, to the k, which is 1. So I'm literally just filling it into that formula on your formula sheet. At the very bottom left, you have a formula on your formula sheet, the tk plus 1 formula. So t1 plus 1 is term 2, which is what we want. 2c1, if I have 2 objects, I choose 1 at a time, I get 2. And then 2 minus 1 is 1. So what's 3 to the power of 1? 3, and then a1. Anything to the power of 1 is just itself. And then negative 2 to the 1 is negative 2. And then people will leave it here. Remember, you're multiplying things. So you need to take all those coefficients, the numbers in front of each of those values, and multiply them together before you're done. So 2 times 3 times negative 2 is what? Negative 12a. So that's my term 2. So I'm going to go minus 12a down here. We agree? And term 3, I want to do same thing. So I'm going to get t2 plus 1, so k is 2 this time. So I'm going to get, this doesn't change, I get 2c2, x, which is 3a, to the 2 minus 2, and then y, which is negative 2, to the k, which is 2. Then term 2 plus 1 is term 3. 2c2 is 1. I have 2 objects, I take them all. No order, so it's like putting them in a backpack, right? Take them and throw in a backpack. Always. Then 2 minus 2 is 0. What's anything to the power of 0? We just discussed this. What's anything to the power of 0? 1. And then negative 2 squared. Type it into your calculator because a lot of you will do this, and then you won't trust your brain, you trust the calculator. But remember, your brain put it in the calculator wrong. Negative 2 squared means negative 2 times negative 2, right? And we know that we were taught when we have a negative times a negative, we get a positive. We agree? But a lot of you will type it into your calculator and you trust your calculator. You type in negative 2 squared without brackets, and it tells you it's negative 4, and you write negative 4. Do you think they'll use the error of negative 4? Yes. When you type it into your calculator, it's doing negative 2 squared. Remember? Everyone's paying attention so you understand why your calculator screws up? What I tell you your calculator will always do? Order of operations. It will always do BEDMAS first. So let's talk about it. Brackets. Are there any brackets? No. Exponents. Remember, this negative is not attached to the 2. That's like having a negative 1 times 2, correct? So what it'll actually do first, it'll do the exponent first. So it'll go 2 squared, which is 4, and then it'll go negative 4. Because it'll treat this negative like it's a negative 1 being multiplied. So it does exponents first, then multiplication. So if I want this to type it in my calculator, what am I going to have to do every single time to force it to do it correctly? Brackets, because it will always do brackets first, right? Remember, your calculator is an order of operations situation. It will always do that. If you go negative 2 in brackets squared, it'll tell you it's positive 4, which is what it actually is. Because you guys don't trust yourselves, you type in your calculator. Whoa, Crystal, grab a mitt, get in the game, wrong term. All right, you get 4. So 1 times 1 times 4 is 4. So here's my trinomial after I've expanded it. Now look. Same answer. Right? Now, if I was given a binomial squared, I would just expand it. Right? Would you not? I would, because it would be faster. But why are we teaching you binomial theorem? Because of this. This is to the 8. So how many terms am I going to get out of this? Total terms. I'm going to get 9 terms total. So that would be x plus y times 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 x plus y, right? So I'm going to have to distribute, 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 distribute. And then I'm going to have to distribute, distribute. And then I'm going to have to collect like terms. And then I'm going to have to put them in descending powers of x. And then there would be my answer. And I'd count the fourth one, right? So that is not faster. A squared, anything to the power of 2 or 3, could be faster by actually expanding it. That's why they don't often give you that. They give you stuff to like 11s and 8s. Okay? So find the fourth term. So the first thing we need to do is get all of our information. Okay? So I know that first off it has to have a plus sign between in order to use the binomial theorem. Because the binomial theorem is x plus y to the n. We agree? So this has a plus sign. So if I have x plus y to the 9, this one's actually easier. X is x. So x is x, y is actually y, which is nice, and n is 9. Those never change. Never, ever, ever change. Doesn't matter if I ask you fourth term, fifth term, ninth term, first term, right? X, y, and n do not change. They are what the binomial is. What's the only thing that is changing every term? K. And what is k? It's always 1 less than the term you're finding. Because the formula is tk plus 1. The formula is tk plus 1 equals. Correct? So I'm going to write out the formula to help myself out. Tk plus 1, nck, x to the n minus k, y to the k. Literally just writing the formula out because it helps a person out when they do that. I want term what? I want term 4. What the heck does k have to be in order for me to write T4? Help me out. K is going to have to be what? 3. We agree? That's why it's always 1 less than the term you're finding, because the formula uses k plus 1, and I need term 4. So I'm going to go T3 plus 1 equals. So I know k equals 3 if I'm looking for the fourth term. That's something to help me out, right? Very important information. N doesn't change, x doesn't change, y doesn't change. They are what they are, right? They come from the binomial. Okay, n is 9. It doesn't change. 9c, my k is 3. So if you want to help yourself out, you could say x equals x. In this case, y equals y. N equals 9. K equals 3. Then you just plug in the numbers for the variables, right? You guys do this in chemistry and physics all the time. You get knowns, fill them in. Often if you're solving something, you have one unknown. You guys do this all the time in science. It's the same thing. Figure out what your 4 things are and plug them in. So we get 9c3. X is x. In this case, it's actually kind of nice. N minus k. So n is 9. K is 3. And then y is y. And then k is 3. So nothing crazy. Yep. Did I put in? No, oh, I wrote this 9 like an idiot. But yes, it is 8. You are correct, my friend. Oh, so much fixing.
Yes, they return.
Thank you for doing that then instead of once I figured it all out and then it's wrong. Okay. What's 8c3? It's what? 56. X to the 5. Y to the 3. And then you're done. You can just write it without brackets. So term 4 is actually 56 x5 y3. And I don't have to go any further because none of these had, it was just x and y. They didn't have coefficients. If they had coefficients, we'd have to multiply all our coefficients at the end, like we did up here, like we did 2 times 3 times negative 2. Okay? I also want to draw your attention back to the previous term. Do you see this? This right here is a 1. Then this is a 2. Then this is a 1. That's Pascal's triangle numbers. So if you look at the back, go back one, I need 3 terms. So I'm going to have 1, 2, 1. So when I do the C's in my calculator, they're going to come out as 1, 2, 1. Okay? That last one had 9, right? It had 9 terms. This has 1, 2, 3, 4, 5, 6, 7. So I have to keep going. 21, 35, 35, 21, 7, 1. And 1, 8, 28, 56, 70, 56, 28, 8, 1. So when we did the 4th term, when they're like this has 1, 2, 3, 4, 5, 6, 7, 8, 9 terms, which is what we needed. The 4th one's front was 56. So Pascal's triangle links itself to just the NC, like the 8C0, 8C1, 8C2, 8C3, 8C4, 8C5. Pascal's could get you those numbers quickly, but that's it. So it just links itself to that very front number, which is the NCK. So you could do that, or you can literally just type in your calculator, which I think is faster anyways. But it does link to Pascal's triangle. Make sense? All right. So I want you guys to try and find the 3rd term. There's 2 key things here. Let's set it up first, and I want you to find it. 3rd term means k is what? K equals 2, because I want T3, k plus 1 would have to be 2, right? What's the problem with this binomial currently? What does it have in the middle of it? A negative, so I have to rewrite it as 2x plus negative 5 to the 7. So this is my x, this is my y, this is my n. So like I said to you, if it's easier, write out all your knowns. So k equals 2, x equals 2x, y equals negative 5, n equals 7. How many terms is this one going to have, total terms? Because that could just be a question. Yeah, the total terms is going to be 8, because it's always one more than n. They could literally just ask you for the total terms. That's one more than n. Solve it out. Plug it into the formula. T, 2 plus 1. And you know you picked k, right? If in the end you have T3, because you need to have T term 3, correct? N is 7C2, x is 2x to the 7 minus 2, and y is negative 5 to the 2. So I get term 3, so I know I did it correctly. What's 7c2? 21? And then 7 minus 2 is 5, so I have to remember to go 2 to the 5, x to the 5. If you're someone who didn't do 2 to the 5 and you wrote 2x to the 5, you're the person who's going to screw this up in that spot, and that's okay. We're going to put a little highlighter and remind ourselves to not be that person who messes up in that spot on the test. Right? We can mess up all we want, but it's when we get to the test, we don't want to make mistakes. Okay, so if you're that person, you did it, you know you are that person. You will probably still do it. So we have to go 2 to the 5, which is actually 32, x to the 5. And then negative 2 squared is positive 25. If you put negative 25, once again, you're the person who's probably typing it in without brackets, you will do that again. And a lot of people will leave it here. Is that the term finalized? No, we have to go 21 times 32 times 25. What do we get? Big number, what is it? 16,800 x to the 5. Okay, flip over. Okay, this one wants us to find, so if they ask you to find term, the 4th term, the 5th term, the 8th term, that should be an easier question, correct? It gives you everything, you just have to solve for k. If it asks for the middle term, that can amp it up a little. Tomorrow we're going to go over the ones that are amped up more. But we can amp it up a little by asking for the middle term. In order to have a middle term, what must we have for number of terms? An odd number of terms, correct? Yeah. Is that not true? You can't have a middle term unless if you have an even number of terms. Remember we talked about like median, mode, mean. In order to have a median, you have to have an odd number of terms, or you have to take the middle 2 terms that were even and divide it by 2. Add them up, divide by 2. Junior high. Same thing here. We have to actually have a middle term, though. We can't have 2 and divide them up, because that doesn't work when you have A's and B's and stuff like that. Okay? So, we know that we have to, in order to have a middle term, we need to have an odd number of terms. True? How do we know this binomial has an odd number of terms? Yeah. The exponent is 10 and it's 1 more than the exponent. So what does our exponent have to be here? Our exponent always has to be what in order to have a middle term? Even. Because the total number of terms has to be odd, which is the total number of terms is 1 more than n. Okay? So why does this binomial have a middle term? The exponent is even. And the total number of terms is 1 more than the exponent. Giving us, or resulting in, an odd number of terms. And a middle term. Now, if this is a written response question, you guys will often do terrible. Because it'll say, why does the binomial have a middle term? You're like, well, because the exponent is 10, 10 plus 1 is 11, 11 is odd, boom, middle term. Okay? You have to explain that when you take the exponent off of the binomial and you add 1 to it, that gives us the total number of terms. Therefore, the total number of terms is 11. And when you have an odd number of terms, you get a middle term, right? Like you have to explain it. So a lot of you guys just give an example. Or they'll say, determine, give me a binomial which would have an odd number of terms and explain why. Or how does a binomial have an odd number, have a middle term or an odd number of terms? And then you have to explain it in generality. You guys will give one example and be like, boof, one example, done. Well, does that prove that it works for everything by giving one example? If you don't define why that one example works? No. So you have to give true explanations, okay? And what has to be true about a binomial in order for it to expand and have a middle term? The exponent on the binomial must be what? Even. And most of you will stop there. Is that enough explanation? Doesn't explain anything about what has to be true. The exponent on the binomial has to be even. To have an odd number of terms. Since the total number of terms. Is equal to the exponent plus 1. Now, some people don't know which term is the middle. Well, if this has an exponent of 10, how many terms are there? 11 total terms. So if people can't visualize which is the middle, I will draw them all out. I will go like this. I will go term 1, term 2, term 3, term 4, term 5, term 6, term 7, term 8, term 9, term 10, term 11, and then I will literally slash them off. Oh, term 6. You know what I mean? Like you can physically draw them all out and draw some off. So when they ask for the middle term of this one, they're indirectly asking you for term 6. Correct? So for this one, it's term 6, which means k is equal to what, guys? K is equal to 5. X is equal to A, Y is equal to B, N is equal to 10. None of that changes. And we just plug it into our formula. So we get T, 5 plus 1, equals N, which is 10C5. If you're anything like me, I don't make mistakes in doing the math. I forget to put the NCK at the front. Way more than I would like to admit. That's often. I just like get into my X and my Y, and I just don't put the NCK. So it is better. The way you will not make an error is if you physically write the formula above it, and then you just fill into the formula. When I do that, I'll never miss my NCK. When I just go from my head, I do. More than I'd like to admit. At least once an assignment, I'll drop the NCK off. So 10C5, and then X, which is A to the N minus K, 10 minus 5, and then Y, which is B to the 5. So I get term 6. Yay, that solidifies that my K was correct. What's 10C5? 52. A5, B5. Nothing has to change. We don't have to do any multiplying because the A and the B don't have coefficients. I'm going to draw your attention to the homework because we're only doing half of it today. We're doing the other half tomorrow, but I'll show you what you can do. It's on the next page. So this one can be done now. This one. This one. This 1, 2, 3, 4. I want to draw your attention to this one. So it is written as 2 minus x over 2 to the 6, which a lot of people will go 2 plus. They'll forget to do this anyways. They'll go xy, but let's pretend we remember. What's an easier way for you guys to mathematically do x over 2? What could we rewrite that as? Let's think about what it was before. So it's x over 2 now. This could have been something like this. Let's pretend this is an x. What could this be? 1/2. This could have been 1/2 times x over 1 technically, and then they go across, right? So it's a lot easier to deal with x over 2 in a binomial form if you write it as 1/2 x to the 6. I'm just going to tell you that because I like it as x over 2, but you guys like it as 1/2 x, because then you'll just take the number and distribute it into the half and then distribute it into the x, right? Up to you. Either one's correct if I put a negative sign on there. then either one is correct. It wasn't without the negative sign. Okay?